Hello guys from Intellipaat. Today we're going to have a workshop on Hadoop Hive data analysis. The data set is going to be a Facebook data set. All right, so let us begin now. We're going to get to the hands-on section where we are actually going to use Hive to analyze some Facebook data. But before that, for the people who are not from a big data background or a data analytics background, just to give you guys a little bit of background information of the technology that we're going to be using today. Let's begin with that. So in the agenda, firstly, we're going to understand what data warehousing is because Hive is a data warehousing technology. We're going to understand what Hive is and how does Hive work in the context of big data and Hadoop as the environment for Hive. And finally, the environment that I am going to be using for this particular tutorial, we're going to discuss that as well, what specifications I am using. And then eventually the hands-on tutorial, which is the Facebook data analysis. So what is data warehousing, right? So it is basically the process of building and utilizing a data warehouse to derive insights from data, right? So a data warehouse is essentially built when data is collected from multiple sources. So data is not only coming from one source, it's coming from multiple sources. To explain that in more depth, imagine that you have an e-commerce business, right? You're running an e-commerce business. So a lot of users come in and log into your website, create their accounts on your website. So they're generating customer data. So that is in a database. The table is called customer maybe. That is the table in their database, right? And then there is the sales data for the inside employees, the sales team and the higher management. They have access to the sales data. So whatever transactions the customers are making, they're also generating sales data from that, and that is also a separate database. So what a data warehouse will do for you, the data warehouse will become the de facto aggregation of all of this data. So you don't need to separately access the customer data and separately access the sales data. Imagine you're from a non-technical background or you're in higher management and you want the combination of all of the data together. You don't want to get into accessing the customer data separately or the sales data separately. So you'll run this data through an ETL tool. An ETL tool is a abbreviation for extract, transform, and load, which basically means that you're preparing the data, you're cleaning the data, you're transforming the data in a manner that is understandable by people, right? So once the data has been extracted, transformed, and loaded into your data warehouse, you can now access it, right? So that is what a data warehouse is. And then the further teams like the business analytics team can take that data from the data warehouse and generate their reports, annual sales reports, or predictive analytics, or just analytics in general, anything that you would like, just the insights and reports from that. So that is the advantage of data warehousing. You don't need to access all of these data sets separately. So what is Hive? Now that we know what a data warehousing is, what we definitely need tools for that, right? There will be a lot of data warehousing tools. So one of them is Hive. But with Hive, your the use case is big data, basically. So Apache Hive is a data warehousing tool built on top of Apache Hadoop, basically. So Hive was built by Facebook, just to give you a little bit of trivia. So they needed a solution for their big data problem because Facebook has a lot of users. So on top of Apache Hadoop, which is an open source technology, they built Apache Hive so that they can basically warehouse all of the data together and perform their analytics and business insights and whatnot. So yeah, Hive is built on top of Apache Hadoop, and it's a data warehousing solution for big data. So how does Hive work? So Hive provides an SQL-like interface, which is an abstracted query language, which we call HiveQL. So HiveQL is basically SQL, but it's just working in the data warehousing tool, which we call Hive. So you can basically write SQL-like statements, and it would run as such to query the data stored in databases and file systems that are integrated with Hadoop, right? So that is the original definition of Hive. And Hive supports the analysis of large data sets stored in the HDFS. So HDFS is the Hadoop distributed file system. So Hadoop runs the file system on its own, where it stores all of the data. So the big data is stored in HDFS, right? So Hive supports the analysis of this data. So you can take all of this data, like you can take the customer data and sales data from the HDFS, combine it together, and create a data warehouse from it using Hive. But nowadays, Hive also supports other file systems like Amazon S3 and Alexio, and a few more as well. Because as times evolve, you need to evolve your compatibility as well. Because there are a lot of distributed file systems as well, which have come up ever since Hadoop came out with the original HDFS. So Hive needs to be updated accordingly. So in my case, what we are going to be doing, we are going to have the HDFS, which is the Hadoop distributed file system, and we can have any sort of data set within that distributed file system. It could be JSON, CSV, TXT, for that matter, and it's within this file system, right? We're going to put it through Hive, and then Hive runs on top of Hadoop. So Hive also takes advantage of Hadoop's processing tool, which is Hadoop MapReduce. So Hive takes advantage of that to calculate its queries, and then we finally get our results or insights or reports. So yeah, let us continue now. So the environment that I am going to be using is going to consist of VMware. So I'm going to be using a virtual machine, and I'm going to be running CentOS on top of that virtual machine. CentOS, for those of you who don't know, is a Linux operating system, and we're going to be using that. And on top of CentOS, we already have Hadoop and Hive installed. So we're going to be using all of these four tools for our little analysis that we're going to be doing today. So let's now move on to the hands-on section, right? So let us look at the data set first that we have. So this is the Facebook data set that I downloaded from Kaggle basically, right? So let us see what data it contains. So we can see that there's a user ID, which is the primary key. So this is the primary key for our data, right? This is unique and not a relevant column at all for our analysis because we wouldn't be needing this. We have age, so this is the age of the user who has created their account on Facebook. This is their date of birth, the year and month. This is their gender, and this is how long they've been on Facebook. So I think this is in the uh, not entirely sure what unit of time this is, but this is the length of how long they've been on Facebook. So I'm assuming this can be days because it cannot be 266 months. It has to be days. And the friends count. So how many friends they have. So right now you can see 0, but as we move down, there are a lot of friends as well on their accounts. And how many friend requests have they sent to other accounts, friendships initiated, how many likes they've made. So in their time operating Facebook, how many posts and statuses and how many basically things they've liked on Facebook and how many likes they have received. And to further subdivide that, we also have how many likes they've received through mobile phones, how many likes they've received through web browser as well, which is the www_like. So basically a standard data set, user data set that Facebook can make public or has made public. So we'll be solving some industry level question sets that would come out of this data set that your employer may ask of you if you're dealing with Hive or big data in general, right? So let us just open up our virtual machine, expand this and log into my account. So I already have Hadoop and Hive installed on top of this CentOS machine. So yeah, all right. So first thing that we would do is actually look at the data set. So here we have our data set. Where is it? Yeah, so here is our data set, which is our sudo underscore facebook.csv. So if I open that up, you can see that it's in the form of comma separated values. So comma is the delimiter between all of these values. And you might be noticing that I've removed the topmost row, which would have contained all the column names. So the reason I've done that because Hive is kind of buggy with headers, right? So even if you set the header to off, it still takes the headers for some reason. So it kind of messes up with the final result, although not by much, but it does mess it up. So that is why I've removed the top row entirely for that reason. and we have the data from below of that. So we can see right from here we have our data, right? The 266 over here, and we have it over here as well. So 266. Yeah. So this is the data that we have. So let's now begin. All right. First thing that I would do is actually transfer this data set that I have, which is the sudo facebook.csv, into my HDFS, which is my Hadoop distributed file system. So it's the same thing. Even if I were dealing with with a huge big data cluster, I would be doing the same thing. So I'll open up the terminal and I'll just expand so that you guys can see the text. Yeah. So the first thing that I would do is type in Hadoop FS. The moment I type Hadoop FS, what we're doing is now we're dealing with the Hadoop file system, not with the local file system that this Linux virtual machine has. And firstly, I'm going to create a folder. And within this folder, I'm going to add this data set. So mkdir, the make directory. And in the present working directory, I'll create a folder. I'll call this folder Facebook data. So let us call this folder Facebook data. When I press enter, the folder has now been created. So now what I want to do, I'll simply, when I minimize this, I'll simply remember this name, which is sudo underscore facebook.csv, and I'll put it into that folder, right? So if I type in Hadoop fs put, so the first parameter for this would be the file on the local file system. So on the Linux, it's in the present working directory. It's sudo, what was it? I forgot. Sudo underscore Facebook. Sudo underscore Facebook dot CSV. This is the file, and I want to put it in Facebook data. So this is the folder that we just created within our HDFS, and I press enter, and then it gets uploaded onto that folder. So verify that, type in Hadoop FS, and just like you would type in Linux, type in ls and type in the folder name, which is Facebook data. Press enter. And we can see that we have our sudo Facebook CSV within our Facebook data folder. So we've successfully uploaded it into our distributed file system. And now Hive can access it. Now it's within the HDFS. Now we can data warehouse it. There are some questions about how to do it in Windows. So Windows is not the suitable operating system to run Hadoop. Although if you just simply do a Google search, you will be able to see where I think we have that video on our YouTube channel as well. So be sure to check that out. We have that video, how to install Hadoop on Windows. So be sure to check that out to get your doubts resolved in that regard. Yeah, and type in Intellipaat in the search to access that. But it's not recommended. It will generally, the practice is doing it on cloud or doing it on a Linux server. So when you're working for an organization, the organization would be following either of two things, right? The first thing that the organization may be following is actually renting a server and manually installing Hadoop on top of it and having a team dedicated to maintaining the Hadoop infrastructure. The second is using cloud services like Google Cloud, AWS, or Microsoft Azure. All right, so enough questions. Let us just get to the second phase, which is minimizing this and opening up another terminal, expanding this a bit and zooming in so that you guys can see. Yeah. So Hive is pretty straightforward. Just simply type in Hive and press enter, and Hive will start up. Right now we are inside our Hive terminal. So it works identical to SQL, and I'll show you how. In SQL, you will type in show databases and semicolon and press enter, and it will show the number of databases and what the databases are. And similarly, in Hive as well, you can do that. So these are all the data warehouses that have been created earlier for various other purposes. So let us create a new database, right? So or just use something like the default. I'll use the default one at least. Use trial. Let us use the trial database, right? And once we do that, we would be within the trial database, just like in SQL, right? And now whatever we do, whatever tables we create, whatever data warehousing we do and put the values into the tables, we would be doing within the trial database, right? So let's now look at the data set actually, and just write our commands accordingly. So we'll have to look at the column. So I'll just simply put it on the side and put it like this. Yeah. So I think the best way to go about it is actually first, just a moment, writing the entire table creation statement down into a document, because when the line changes within the terminal, within the Hive is kind of buggy with that. Whenever you change the line in the terminal, it sort of writes the text in a weird fashion. So that is why I want to write the entire command within a document first before I actually execute it on Hive. So let's call this Hive command. Open this up and let's write our table creation statement. So create table like in SQL, and we will have to call the table something. So let us call the table FB, right, for Facebook. Open it up. So the user ID, let us look at the user ID. It is an integer value. It's not a big int. It's the number of digits is almost consistent, not a big int. And the user ID would be integer in that case. So we simply type in ID, which would be the name of the column, and int, which would be the data type of this particular column. Right. So the first column is done. Let us look at the second column, age. Int, no issues with that. Age is integer. Then we have date of birth, day. So let's call this day, and the obviously the value would be integer because it's 1 to 31. And we have a date of birth year, so that is integer as well. So year, int, right? Date of birth, month, so that is integer as well. So let's call this month and call it int. So now we're on to gender. So gender is not an integer, so we'll simply type in gender, and that would be a string. So gender would be a string, male, female, male, female. That would come under string. Tenure can come into integer. So let us type in tenure. Type in int. Friend count, definitely integer. Let's call this friend. Friends. Let's call it that. We don't have to be since we are not actually matching any headers right now. These column names are irrelevant. We can name the columns whatever we want on our end, right? So that is another advantage of data warehousing. You're not limited by what the database is, right? You can simply manipulate it according to your needs and create new columns as well. So friends would be integer, and friend count. Okay, friend count has been done. Friendships initiated. So friend, spelling error. Yeah. Okay, friend underscore init, and that would be integer as well. So let's go furthermore. So what do we have after friends initiated? We have likes. So likes, simply just a moment. Likes would be integer as well. Likes underscore received. Let's call it likes underscore RECD. That would be integer as well. So we're now in the second line. So this is where if we were doing it in the terminal, we would have faced an issue. So that is int. Likes received is int. Then we have mobile likes. So let's call this m likes, and that would be int as well. And then we have mobile likes received, which is m likes RECD int. Then we have website likes. So website like, and that is int. Well, website likes underscore received, that is integer as well. And any more data? Okay, that would be it. So we close the bracket off because this would be the template for our table creation. Now what? Now we have to specify that these values are actually separated by commas. You are currently seeing the data in an Excel sheet. So this is actually a CSV data format, but the Excel automatically creates the tables and everything, creates the columns and everything. So you're not actually seeing it in that fashion, but it's actually comma separated. If you opened it up with a text file, you will see that it's comma separated. So firstly, we have to specify that the row format is delimited, right? Which means that the row is delimited by a particular character, and fields are fields terminated by. So now you have to specify the delimiter. What is delimiting these particular data points? So in our case, it's comma. So comma is the one, since it's a comma separated file, comma is the thing that is separating all of these data points, right? So this is there. So now we have to reference to our source of data. So the source of data is in the HDFS, right? So we have to type in stored as text file, because our data is stored as a text file over there. Location. Now we have to put in the location that we have, right? So location would be the absolute path to our Facebook data, right? So in my HDFS, it's user training. If I go back just a moment, yeah, user training, and within that, if I simply open up my other terminal again, just a moment, yeah, this one. So I can see the folder name is called Facebook data, and yeah, we only need to refer to that to get our data. So we get back there, yeah. So Facebook data, and put in a slash over there just to specify that all of the data that is within this particular directory will be picked up. So doesn't matter even if there were multiple files, right, within the Facebook data folder, they would have been picked up as well. So right now we only have one file though. So we copy this, Control plus C, and we go back to our Hive terminal. We expand this and we paste it over here, right? If I simply scroll to the side and put in a semicolon over here and press enter, then if I scroll back, I can see that the query is okay and the time taken is 0.756 seconds. Now we have warehoused the data from here. We had our HDFS server and we created a folder within that HDFS server, and we had our CSV file within this. We uploaded it, right? This is our big data. This could be gigabytes to terabytes to petabytes of data within this Facebook data folder. Does not matter. We would do the exact same thing for that as well. But except Hive is very well suited to deal with large amounts of data, depending on the server, depending on the big data cluster that you have. Okay. So let us now type in select asterisk from FP and limit the number of values to 2 so that we don't entirely flood the entire terminal with data, because there were a lot of data points. And press semicolon. We do that, we get our first 2 rows of data. So these are the questions that we're going to be solving today. Are you guys able to see? We have headers in our create command, but Hive is not showing. What basically what happens is in Hive, you have to basically set that parameter to show the headers, right? So with this particular version of Hive, it's kind of buggy because it works sometimes, it does not work other times, right? So that is why I removed the headers from my data set in the first place. And for that reason also, uh, you go into the particular options that Hive has, you set a particular value to true, and then the headers display. But for our use case, we wouldn't be needing that. So I'm not doing it right now. Although it's kind of buggy, so I'm not entirely sure it would happen at all in the first place. But in Spark, all of these problems do not exist. In Hive, they somewhat exist because Hive is an older technology in comparison with the newer ones, where these problems do not exist. Find out the total number of users in this data set. So for those of you who are from an SQL background, this is a pretty easy question. This is one of the most basic questions that are ever asked, and the answer to that is quite simple. Quite simple. So what would be the total number of users, right? So you simply have to run a count on the number of rows in the data set. Simply you have to do that because each row corresponds to one user, and if you count the total number of rows, you will get the total number of users. So quite simple, quite straightforward. So let me do that. So the way you would do that is select, and like SQL, you would type in count, and within count, you'll give in the asterisk so that you count everything that is there. So asterisk is indicative of everything. And then you give in the table name from FB, right? So that is the table name. Put in a semicolon, press enter. Now the fun part begins. We can see that it's not actually doing it normally. It's running a MapReduce job, right? So right now you might be thinking this is kind of futile for a 5 megabyte data set, but that's where you're wrong. The thing is, when you're dealing with terabytes of data set, it would take the exact same time, right? So you might not be quite impressed with how much time it took to analyze this 5 megabytes of data, but even if we are dealing with terabytes of data, it would take the exact amount of time and give us the results, right? Like 15 seconds in this case. So that is quite a good speed for when you're analyzing big data. All right. So let us look at the other questions, which is find out the number of Facebook users above the age of 25. So again, your employer can ask you, depending on whether the business analysts in your organization are doing a market study. So you're working as a data analyst, a big data analyst in their department under them. So what they'll ask of you is, please find this out for me. Please find out the number of Facebook users who are above the age of 25. We're doing a survey. We're doing a statistical analysis of our market base. So you need to find that out, and much more complex queries as well in that regard. So let me just do that as well. So we just simply have to look at the column, which is this age column, right? And we simply have to find out all of the count, which is above the age of 25, right? Quite straightforward. I think some people are also able to answer it. Yeah. So Nitin is able to answer it. He's also taken up our course as well in big data. So let us just do that. Select. So how do we do? How do we go about it? We go about it like count. We calculate the count over here from FP as well as our table name. But here we're not simply doing that. We're also adding a clause. So that's the where clause, and where age, which is an integer value, is greater. So is that greater? Above the age of 25? Yes, it's not. It's greater. It's not greater than equal to. And then we press a semicolon. A MapReduce job will start. And once the MapReduce job has finished executing, we'll get our result as well. So by the way, we didn't discuss the result of the previous question. We had about 99,003 records, those were the number of users that were available in our data set. So that was 99,003. So that was the result over there. We didn't actually discuss that. And right now we can see that the number of users who are above the age of 25 are 56,676. Quite straightforward, right? All right. Let me look at some questions. How do we download the data from Facebook? I simply Googled Facebook dataset on Kaggle, and the first result that came up was of Kaggle. So it was a 5 megabyte dataset, so I downloaded it from there. You can do the same as well. Data sets are quite abundant. Obviously, you cannot get the deeper insights data of Facebook. All of the organizations keep it secret. You can only have access to the data sets that they've actually made public. So in the case of Facebook, you have this. In the case of Amazon, you have their product reviews data set that they make public, but they do not make any other data set public. So you have all of those things. The total number of users are distinct. Yes, they are distinct. So the reason I know they are distinct is because each row has a unique user ID. So this is the primary key, right? Essentially, and the primary key ensures that all of the rows are distinct because all of these rows are corresponding to new users on Facebook. I mean, it's basically corresponding to unique users on Facebook, not new users on Facebook, unique users on Facebook. Okay, when we did the first query, we did not run the MapReduce process. No, we actually did. What was the first query that we did? Yeah, so select does not require MapReduce, right? We don't require MapReduce for select because we've already warehoused the data. It's basically showing what we have. Whenever we are calculating anything, right? For in this case, this is a calculation. This is a function. Count is a function that is present in HiveQL, right? So that is a function. And whenever there is a calculation involved, Hive knows that it has to perform MapReduce to actually perform that calculation in a much faster amount of time, in a parallel amount of time, so that it can run that query across all of the data nodes that are there. So yeah. So say the file sudo Facebook CSV was divided into 3 parts and put on 3 systems, right? And all of those 3 systems are connected together. So what would happen is on one system, 1/3 of this particular MapReduce job will run on the other system, 1/3, and on the other system 1/3 as well. So that way we are reducing the time in which the entire operation would have been executed on one system. So essentially by the third of the time, we are basically taking third of the time. All right, so let us look at the next question, which is, do male Facebook users tend to have more friends or female users? So these are also some questions that your employers can ask of you. So basic questions. As you can see here, the employer is not exactly telling you what to do. So he's just basically asking you a question. You have the data set and you need to think about what you have to do over here. So this is where your analytical brain comes in. So basically what will happen is my approach to this is my approach. You can take another approach to this depending on the data that you have. My approach to this would be, I would calculate the average. I would calculate the average friends that a male Facebook user has, and then I would calculate the average friends that a female user has, right? We can do it in one step, but I'll do it in 2 steps just to show you guys. Yeah, so let us do that first. Select, and let's look at the table names that we have. So select, what would we be doing here? We would be dealing with gender firstly. So let's deal with gender first, and then we would be dealing with more friends. So we would be dealing with the number of friends. So gender and friends are 2 column names that we are dealing with right now. So select, how would we go about it? Average. So average is a function in SQL. You can also use group by in it. I'll be using it in another question that would be following this. Firstly, I'll show you without using group by. So what I would be doing here is calculating the average of friends. So I would type in friends from FP. So that would be the entirety of it, but I need to add a clause over here. So firstly, I want to calculate the male. So where gender. So we are adding a where clause where gender equals to. Now we cannot simply type in male. That is something you not do. You have to type in equals to, and you have to put in a single quote or a double quote. It's a string value, and you have to type in male. When you do that, and you press semicolon and you press enter, that will start a MapReduce job, and it will only calculate the average of the friends where the gender is male, basically. So at an average, we get about 165 for male, right? So let us do that for female. Bring the previous statement up and change this over to female, right? And press enter. So let us see which particular gender has more friends on an average. I'm betting on female. So yeah, we can see that there is a quite a difference. We can see that in the male it's about 165, and in the female it's about 241. So even if you're doing as a businessman, right? You imagine you own Facebook, right? So you're calculating as to which target audience is more marketable, right? You want to market your product towards females more because they tend to be more active on social media according to statistics. It's just basic mathematics, right? So this is how business analysts basically get their insights, and then they forward their insights to the marketing team, and then the marketing team does what they have to do. So that is how these businesses are so successful, like these Amazon and Google and Microsoft and whatnot, basically. Yeah. So yeah, a lot of banter going on in the questions as well. Yeah, so let us focus on the next question. So firstly, I'll just do the group by ones to just show you guys how to do it all together. So we do the average of friends, and we also take another column, say gender, right? So in order to group by, you need to select gender as well in the column, in the selection bar. Otherwise, it wouldn't actually register in the group by, right? So you do that, and then you type in at the end, instead of where, you type in group by gender, right? You do that. And I think that should work, and press enter. So that would start another map reduce job, but we will get both of these results together. So Facebook has three options actually. So we have male, we have female, and there's the one option that is basically not disclosing, right? So we can see that male has 165, as we discussed before, female has 245, and the not disclosed would be 184, right? So this is basically we have this in order of group by. So that is how you use group by and get all of the results at one, and that's at once, and that is how you'll basically do it, right? So let's look at how many likes do young people receive on Facebook opposed to older members on Facebook. So naturally, I think you have some idea of this answer. So this analysis is basically about, are younger people on Facebook receiving more likes than older people on Facebook, right? So I think they do. So let us just verify that for once. So here also we'll do average. At least that is my approach. You can use other approaches as well. Whatever your approach would be, you can also use sum, but that would not give you the exact mean of the data. It will just give you the total of that. So one person could be an outlier. So it's not exactly a good parameter to base your entire decision on, because one person could have a lot of what would you say, likes, and that would just skew the entire data set altogether. One person could be a celebrity for that matter. So that is why it is better to do it at an average. So let's do that. Select, and then we have to find out the, let's use the age bracket of above 13. Above 13 to 25, that would be our younger demographic, right? So let us use the above 13 to 25 for our young demographic, because 13 is the Facebook age limit, age limitation, and you have to basically be above 13 to be able to create an account on Facebook. So select, what were we doing? Likes underscore received, and we put it into an average. So we are calculating the average likes received from FP, and where age is greater than equal to 13 and age is smaller than equals to 25. So that is, I think, appropriate for a young demographic, and we press enter. So let us finish with the map reduce job and get the result for that. Yeah, so we get about 200 likes, right? So this is the average of young people. Let us look at the average of old people. So let us take the age demographic of 35 to 35 and above, basically. So not exactly old people, basically people who are at the more adult side of Facebook, basically. So let us just find that out. Select, select, what would it be? Just simply bring that up again. Why am I typing it again? Yeah. So I'll remove this, and the age would be greater than 35. Put that in, semicolon that up, and press enter. So we'll wait for the results. Let me look at the questions. So for those of you who for those of you who are from an SQL background, right, from a database management background, they will absolutely have a blast doing this, because it's the easiest thing. Even Spark for that matter, PySpark for that matter, Hive for that matter, you'll have an absolute blast doing it, because you only need to understand the architecture really well. And after you understood the architecture, after you understood HDFS and other distributed file systems, if you want to move on to cloud, depending on whatever your interests are, you can basically use your SQL knowledge to a really great extent in this particular domain, because it's entirely that when using Hive, or majority of that when using Spark. So as we can see, there's a clear-cut difference. In the younger audiences, in the younger Facebook users, we had an average of about 200 likes, right, on their account received. And on an average for adult Facebook audiences above the age of 35, we have about 103, right? So there's a clear difference. We had a doubt. We thought that this would be the case, but we wanted to verify it. We cannot just go out on a limb and say that, yeah, that is the case, because old people are less active, so they will have lesser likes. But we needed proof for that. Now we have proof for that. So that is how you will go about it. So let me look at some other questions. Find out the count of Facebook users for each birthday month. So this is quite straightforward. We'll use the group by and we'll use the month in this case. So let's find out which month has the people with in their date of birth, according to month, which month has the higher number of Facebook users. So select month. So month is something that we have to select because we're going to grouping it by average, not average. What we're doing, we're doing count, count, and then we're doing from FB group by month, put in a semicolon, press enter, and that would give you a list of 1 to 12 months, and correspondingly it will give you the number of accounts that exist for those months. So we can see January has the highest number of Facebook users. We have March 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So corresponding to December, we have 7,894, right? So we can see that for some reason, right, January has more Facebook users. So one could say, imagine that people basically start their New Year's with creating a Facebook account. Somebody thought that I will not create a Facebook account until the new year begins. So a lot of things can be speculated. That is why it gets interesting, right? Why does the January month have that skew? Why does it have more Facebook users when at an average it's about 7,500 from February to December? Why does January have that boost? So a lot of things intrigue you. Basically, Facebook can target January as a fruitful month. It can run a aggressive marketing campaign in January because it sees that users tend to create more accounts during January. So you get the idea. Let us look at, do young members use mobile phones or computers for Facebook browsing? And do adult members use mobile phones or computers for Facebook browsing? So we want to find out, in this day and age where a computer is not required to browse Facebook. You can use your smartphone for that. You can use other devices for that. You can use your TV for that. You can use your PlayStation for that. You can use a lot of devices. Every device has a web browser these days. Every device is smart. You can log into Facebook from that. So our database, particularly, not database, data set particularly, has two other columns as well, which is the mobile likes received and the website likes received, right? So this divides the likes received into two subcategories. So Facebook is also monitoring whether you're actually receiving those particular likes, actually making those particular likes from a mobile device or a web browser. So I'm not actually discussing the likes received column. We're discussing the mobile likes and the www_likes column. This is the number of likes that you have made using those devices. So let us look at the stats. So my assumption would be that young members are more uh, young members use mobile phones more, while older members use computers more. Although I can be wrong. Let us just check that. Select. When we go to check that, how do we go about it? We go about it in a way. Average or count. We go about it with an average. So let us look at that. Average M likes, right? And what we could do over here from FB, where let's use the initial age bracket, which was age greater than equals to 13 and age less than equals to 25. Put in a semicolon, press, I think that would be it, press enter. So yeah, for those of you who are between the ages of 25 to 35, I'm not discounting you entirely. I'm just showing you an example. Please do not be offended. Yeah, so we get our result, which is 123. So that is the average. So this is the average number of likes of young users using mobile phones. Let us look at how how much phones they use. I'll just look at both of those things at once, right? So average M likes and average website likes. So let us look at those two side by side. We can see that there's a difference. So on a mobile phone, young people tend to like more and they tend to use computer devices less, right? So that basically gives us that result. So what if we turn the tables and put it to for the adult audiences? Let's look at that, age greater than 35. I think that would be it, and press enter. Let's see that. So we can definitely see that I was wrong. So what happens is basically even older people are using mobile phones more. Nobody's using computers. So that was a wrong assessment. So that would not be what I would base my business model on. We can see that there's a difference between the number of likes that they're making in general. The older people are making less likes, while the younger people are making more likes. So that was something that we proved earlier on as well. But yeah, the older people are using phones as well, so it's essentially the same difference in a way. So they tend to use computer devices less. So yeah, thank you for attending. Hope you have a wonderful day ahead of you.